Good afternoon, everyone. Thanks for having me here today, and looking forward to sort of give you the perspective from the builder side, the boots on the ground. So, just a little bit about where I'm coming from. Proudly a Red Seal carpenter by trade. Started in this business as a laborer, and have worked through sort of all the different ranks inside of a construction entity. And so I'm going to give you the perspective of that, which is really the boots on the ground, and how to try and implement some of these technologies into the actual execution of the work, right? So there's a pretty big gap there between, the level of sophistication happening and what we've seen today to the level of sophistication on the ground where, 90% of the businesses that are construction in this space are fewer than 20 employees, and they don't have the ability to carry that value forward. Just a brief note about the company. So we're a small boutique firm based out of North Vancouver. We've got just under 60 on our payroll. It's now made up of carpenters, project managers, engineers, and architects, all practicing construction management. So we've retooled the business a little bit to be able to try and hedge this challenge of implementing some of these technologies and sort of the gaps between the thinkers and the doers in the world, right? We have to get together in the same room. So we've made some good progress there. We've got two groups, really, Part 9 housing group and a Part 3 focusing on ICI. We try to avoid multifamily if we can. I'm going to present two projects today that are executed. They're completed, they're occupied, and they have a lot of similarities to them. And I'll start with PH1. So this is a 3-story mixed-use building constructed in North Vancouver. Primary structure, glulam and CLT, built to Passive House standards, and contains a restaurant on the bottom floor and 2 levels of office above. It's just under 700 square meters in size, so it's not a big project, but it's a mighty one. There's a number of complications. We've got projects on the go now that are 10 times the size that are easier than this project was. And a wonderful team to be able to work with, and Hemsworth Architects was the architect in charge. Dean Schwadike led that, and Equilibrium, a Katera company at the time, was the structural engineer, led by Robert Malchek, who's now formed Timber Engineering. Just a quick shout out, there's over 150 people that touched this project, and they all added a piece of value to it, from the labor, boots on the ground, right up to the prime consultants and the sub-consultants. And so it takes a team to execute something like this collaboratively. And a special shout out to the owners for being innovative and forward thinking. This was 5 or 6 years ago when this thing started. And about 3 years sort of held up in the development permit process to change a text amendment from the word this to that. And so it took a while to get off the ground, but it was very forward thinking at the time. Just context on site location, logistics. So that's the site there, bottom of North Van. If you know, it's right across the street from the Polygon Gallery, beautiful building by Patcow Architects. 25 by 140 site, 0 lot line conditions, and a neighboring property on the corner. Pretty active public thoroughfare there, bus route, and a very active sort of community. Our scope as the builder, I put in quotations, as we've found over the last 10 years, as a builder, our scope of work seems to have evolved a little bit as the industry evolves. And so we provided standard construction management services here under CCDC 5B. We provided digitization services from a virtual construction perspective, as we call it, because that's just exactly what it is. I'll get into that later. We were also able to provide prefab and mass timber trade assist because we have that in-house. We've got about 30 carpenters on our staff and specialists in this. And then we were also there to be able to provide passive house expertise. So we've completed a number of certified passive house projects across both the Part 9 and Part 3 sectors. And so understanding air tightness and ventilation strategies and things to try and optimize this building to actually be able to get it built. There was a point in time where this building probably wasn't going to go because it didn't pencil, but we worked hard as a group to be able to make that happen. So from the digital side, digitally integrated design and construction process, it's a bit of a mouthful, but that's what we've kind of come to land on. And I'm just wondering in the back, can you make my the screen slide bigger here? I've got bad eyesight. Yeah, thanks. Sorry about that. Yeah, I remember what I said. Yeah, so some of the points here, the primary software we used was Revit and CADWorks, so basic off-the-shelf stuff. We use virtual construction as a methodology, and I think it's important to try and understand the context of that. We talked about sort of the ambiguity in BIM, right? What is BIM? BIM for design, BIM for construction, there's quite a bit of confusion in the industry what that actually means. And so we use virtual construction as a methodology in what we do and as a tool to be able to manage projects. This develops trust and transparency. We're on board very early at a concept schematic stage, which is where we want to be so that we can add value from a construction lens into the design process. And in this case, we introduced and facilitated integrated design process in collaboration with the core team to try and get regular meetings going and allow the team to get together regularly during the design phase, where often we're not even present and we receive a set of documents. So early engagement of sub-trades as well. So let's bring the subject matter experts to the table at the early stage of concept and allow them to help inform the design and allow them to provide their expertise, which may save time and money and technical detailing later and sort of eliminate redundancies. And just really the shift of intensity that's required. So can we get to 100% design definition before we start constructing? I mean, it seems logical. I don't know if anyone's ever gotten there. And so can we move the intensity or sort of the tolerated gaps that we get to in today's market forward and try and reach a manufacturing view on what we're doing? So I'll now sort of break into how we leverage virtual construction to create shareholder value. So some shots here of the team meeting in our office in different spots and actually virtually constructing the building. So we use this to de-risk the project, as a quantity takeoff tool, as a collaboration tool, as a project management methodology, and of course visualization from the 3D model that we get, which seems to be really popular to put up as eye candy, but the underlying data inside of that model is what we want as a constructor, because we're using that data for estimating and other things, and really trying to create a single source of truth for us as a builder. So we've got this model that we built, and it's modeled right down to the rebar and right down to the screws. We'll be able to reference that model during the course of construction, actually be able to carry the value of the design work that was done forward through to construction. I think we see that often where a very great design models come through, and I hear that at that point it might die at construction, and then the construction group just takes it and just goes and kind of figures it out in an old-fashioned way, and that may lead to less effort in the design potentially, right? If you know they're not going to use that, then why would we put more efforts into designing that in sort of a 3D environment? So just something to consider there, that the construction industry is not sophisticated, right? It's getting better. Where there's builders out there and great groups out there, but the majority is still, we still got a fax, last week for a tender, right? So, we're just at the back end of learning email in our industry, right? I think everyone's got it now, but it takes a while. It's going to take some time to adapt, and so we got to meet the gap somewhere in the middle through incremental work and effort. And so I think having us as a builder, construction manager at the table, as a partner and an integrator to the construction side of the project, along with the prime consultant, who's the integrator of the design side of the process, how can we not be sitting in the same rooms together earlier and integrating these two things? Let's eliminate that line and get together sooner. And it's going to allow us to do things and try and optimize, eliminate redundancies, and find ways to get projects built. I think there was a comment about 20 projects designed and one built, and that's sad, and often it comes down to cost. And so we really believe there's 20% of waste inside of these things. The fees, the services, the costing, the goods and services that are put into there, they all factor in the redundancies, inefficiencies, and sort of tolerated acceptable ways that things go in our industry. And so let's work on trying to eliminate those. Just another shot there in the office of these sessions where we would have the architect, engineer, boots on the ground, crane operator, anyone that's going to be critical in the sequencing of the project that we're executing. Some more shots there. Early days, digital quantity takeoff. So once we have this model, this single source of truth that's an actual model that's virtually constructed to a 400 level of detail, we can now extract the data from that model and use it. The most accurate quantity estimate you're ever going to get is going to come from a model like that versus a manual process or a Bluebeam or a PlanSwift. So being able to move on that and be able to have live action on that model, to be able to have quantifiable conversations in value engineering and these type of instances that we all know we face regularly in projects, and is sometimes a frustration point or a point of waste. In this case, this wasn't a BIM project, so it wasn't that most of the consultants were in AutoCAD 2D. There was a bit of SketchUp models floating around, but we made the decision to model mechanical in-house because it's so critical, and I think that's one of the, I guess, the key points from the integration side. So having the modeling technician, having the installer, having the project manager all in-house on our team allows that to be very agile when we're going through these processes. You know, the technician can lean over to the project team or the construction expert and say, hey, how is this actually going to go in reality? Thanks. And that avoids sort of trying to bounce that for a 3-week kind of turnaround to get a decision made on a shop drawing or something like that. And so that's just retooling the business to be able to get ready for, you know, the robotics world and the other things that are still quite far away from where we think we're at today as a construction industry. And just some more shots here. I think we've all seen sort of the constructability analysis and the clash detection or clash deterrent to try and move through these projects successfully. We were able to hyperimpose the digital model onto the site here. This is a very logistically challenging property, and so use this to be able to try and figure out what kind of craning we're going to use. In this case, you know, we ended up going with a mobile crane instead of a self-erector crane, which saved quite a bit of money on the project. And we wouldn't have been able to do that without these tools. Play a short video here, sort of the result of the virtual construction of this building. So, you know, slab on grade, there's no parking under this building. It's in North End. And you can see sort of the final digital sequencing model. This is the result of probably 6 months of effort, multiple sessions, and actually constructing the building piece by piece. Originally, it was a 21-day install, and this north wall you'll see going in a second, which is the wall adjacent to the zero lot line building next door. Typically, you'd see that as concrete block, right? That was always going to go in first, right? From the engineers, the architect, us, you know, when we started this, that wall was going to go in first. There was no other way. And through the course of these sessions, you know, and a stupid comment from a carpenter who was sitting in on the session, right? He said, well, what if we put the building up and put the wall between the two buildings, right? And that's all it took for the group to start exploring that and then realize that, you know, that's a better way. And that brought us down to 15 days and then down to 10 days in reality to install this building and envelope. And I'll show you that in a second here. I guess now moving into prefabrication. I could catch my breath here. I'm trying to get through a lot of content. But sort of moving into prefabrication, so leveraging virtual construction to be able to prefabricate this building, which was hugely successful. Just some side notes here. You can see we call ourselves prefab gypsies, so we'll just find a yard, someone will allow us to be there, and we'll set up our sort of prefab shop. And we did that here 7 kilometers away on a 2-acre site. Waiting for a development permit. So there's no shortage of those out there, is there. So we were able to prefab everything out in our yard there. Very rudimentary fabrication. So we're just taking what we do on site and moving it off site somewhere else. We're trying to take sequence of construction and move it into parallel, right, to save time. And so trying to pick off little pieces one by one, 2 days, 3 days, 5 days. How much time can we save in running things in parallel? So you can see our prefabrication hut there. We were able to prefabricate a number of things, sort of a shot of the underslab insulation that was fabricated off-site. It's a passive house building, so there's like 2 feet of insulation under the building. But we were able to do that. So site work's going on. The foam components are being constructed and labeled in the yard, and then bring that to site and install it in 2 days versus having that workflow occur on site in 5 days. So incremental saving of 3 days, but it all adds up. This is a shot of the elevator pit. So really the only sub-slab piece of concrete here is the elevator pit. So we precast that off-site in the yard and dropped it in, damp proofing and all, backfilled it, and sort of saves kind of a 5-day workflow that kind of would hang up that corner of the site and have to wait before we can move forward with the subsequent slab work. Pre-installing hangers, bolts, brace bays, as much as we could put on the ground, safer and higher quality. We did that also in the yard. Weather-resistant barrier. the panels here. Remember, it's a passive house, and what we know about passive house is we need to build it airtight to a certain standard. One of the primary project objectives was to receive passive house certification. So we were sweating on this one for sure, because there was over 60 breaks in the continuity of the air barrier, and we know that that's not good. And so we had to come up with systems to be able to figure that out in prefab. Insulation, clips, counter flashings, and some metal protection board went on these panels. So there's a shot of that north wall in the yard ready to be installed. BC Passive House up in Pemberton provided the exterior envelope SIP panels, which sort of clipped onto the vertical structure. And another shot of that. So get into the installation piece. Pretty blocked out schedule here of 10 days, 8 days for the structure, 2 days for the envelope. And again, just sort of reiterating, we were 21 days, brought it down to 15, got to 10 in in the digital build, and then executed that on site. Again, just touching on, the days of drawings on site, and stacks of ASIs and other things to try and figure out what, where things are at. We've got model, we've got the source of truth that we trust because we built it from a construction mentality, and so we're using that on site to run the building. The north wall here, I just highlight some of the slides here just to move it along, but you can see sort of the narrow conditions here to be able to slip this wall between the existing building that the new building we built and the existing building that was there. And just some fantastic, we had good weather. You can see that was lucky. Fantastic shots here from KK Law, and some of the belt and suspenders air tightness work that we had to do to be able to meet the project objectives. You can see here there's less than 20 mils clearance between the building and the new building. And then the shot of the inside with the air detailing wrapping into the building. And you can see here the photo on the left of sort of taping that air joint. So the air barrier really went outside to inside and outside to inside, and then capped with plywood strip, and the CLT remained exposed inside the building, which was beautiful. Just a shot of that wall. Sort of going from the panels then wrap the building, and just kind of some slides just sort of highlighting like the digitized process into reality, and really seeing this through, right? There's been not too many projects that have been able to execute this level of prefabrication and do that successfully. So the shot of a beautiful kind of timeless piece of architecture there, for sure. It was meant to be there. Some shots of the inside, and I'll just play like a sort of a short video that'll recap this project and move on to the next one. Is that 40 minutes already? Done? Well, what time do you want me done? Minutes. Thank you. Yeah, we spent more time taking photos and video than project managing there, it looked like. But from slab to roof going on 10 days. So full structure, building envelope, windows would be going in. I'll mention we demoed the existing building in January 2020 and basically broke ground the end of February. And so we all know what happened. I think early March of that year was this global pandemic thing, so we hadn't thought about that. But overall, we were able to get through the project successfully. A little bit behind schedule, but some of the supply chain things got us there, and of course, the panic in the marketplace that occurred for a brief period there was fun to manage. So overall, recapping the project here, just some notes. So one of the first certified Passive House office buildings in North America. Pending, be the first certified restaurant in the world for Passive House. 10 days of on-site construction spent on the superstructure envelope. No on-site modifications were needed. And I believe the first CLT exposed firewall in BC, a 2-hour rated firewall left exposed. And super airtight. We achieved the airtightness of 0.45 at 50 pascals, and the superintendent was able to get a good night's sleep once we had that testing done. So overall, pretty successful project. From a VDC or construction lessons learned, there's an incredible amount of value proposition here. We just need to mine for it. We completely changed the erection sequencing of this project during digital assembly. We were able to get high quality quantity takeoffs out of the model and be able to use the model for value engineering. Quality and reliable logistics and crane planning changed the way we probably would have executed the project if we weren't using these tools. So, and to the benefit of the project, we developed a high level of trust with the owners group on how this was going to go. And that led to a pretty innovative contract approach, in which is unheard of in commercial construction, where the owner elected to leave the contract open because they didn't want to pay a risk premium because they couldn't find the risk. And our risk registry was a little lean. Like, we built the building already 3 or 4 times. We're very confident how it was going to get executed, and so it was delivered. It was delivered under budget by 10%. There were 0 change orders to the prime contract, and so that's something special right there. And really, IDP, integrated design process, is just critical and hugely successful. So, like, let's get together sooner as builders and design teams, and let's solve these issues together. And I think it's a win-win and can optimize the process and eliminate the redundancies and silos that we face that are costing everyone time and money in these projects. So I'll move forward now quickly through On5. I just want to highlight sort of some of the advancements that we made from the Lonsdale project to the On5 project. We were super fortunate to be able to have one project start right after the next, and with the same core team. So same team on our end on the construction side, same architect, same engineer, and then a mix of sub-consultants underneath. And so it was hugely valuable to be able to repeat this process over and apply our learnings immediately into the next piece. And so if we can find repetition like this in the marketplace, then we're going to be able to solve some of these issues. This project's a little bit bigger, just over 840 square meters, completed 2022. Robert Malchek is a structural engineer and the owner who occupies the building, so there was definitely an interesting dynamic there on the delivery and setup of this, and the rest of the team's noted there. This site is more tricky than the last. Same size, 25 feet by 140. Now we have a building on either side, and you wouldn't believe me, but the next door had an antique lamp store inside of it. So that was one that was like, okay, this could be interesting. One of a kind lamps next to a construction site. So we didn't break any, and everything worked well. And overall, but you can see sort of a challenging site, bustling Mount Pleasant. We ended up having to close Ontario Street down for a couple of weeks, and so challenging with the city and other things. Our scope here is largely the same scope, same team, and we were able to sort of evolve on some of the things that we learned on in the first project. Same thing here. We got on board earlier this time because we all agreed that was going to be better. We advanced the integrated design process and try to make that more efficient so that we could have more efficient regular meetings and not tie up too much time. Earlier involvement of subject matter experts from the trades, glazing, mass timber suppliers. We want them at the table. They're going to inform the IFC documents. Really is I think what we got to, and then just further trying to push the intensity of the consultants to know that we're virtually building this building, and the delay of not having the complete set for the prime consultant to be able to coordinate delays our virtual build. Just so view that the same as if we were in the ground, where everyone sort of waits till the panic moment, and then all the site instructions start coming in. Like, this incredible amount of inefficiency there, and that's just normal. And that's the stuff that I was talking about earlier. Like, we got to get that out of there. It's costing so much money to the project, and this is what we believe the way to do that. And then we learned our lesson on level of detail and the timing of modeling, right? So. We threw a huge amount of work in the garbage because we modeled too early on Lonsdale project, and we had to start over because the design changed so significantly that the process of virtually constructing is where the value is unlocked, right? So if it changes too much, then we really have to change gears and start over. So we learned that, and we waited in this case where we were able to use design models to do some of the quantity takeoff stuff and some of the other value that we're pulling out of here, early stuff, and then we'll move to the virtual construction model once we've reached a reasonable level of design definition. Advancements to that. So we moved into like a much more sophisticated, shop drawing level of detail with labeling, and we broke this building down into blocks on how it's going to be constructed. It's an innovative building. There's no posts and there's no beams, okay? So there's no glulam posts, no glulam beams. It's just CLT vertical and CLT floors hanging off angles. So super innovative structure. And we were able to advance this and really sophisticate our processes internally and lead to sheets which allow us to understand where's this component in our yard, where's this component on site, what load will it be on, right? We've got a very tight street, so we're just cycling loads of components intermittently throughout the day. And we were able to really break this down, and now today advance further to adding, what are those Apple things you stick on, air tags, adding air tags to things and seeing where things are and just playing around with that stuff. But this is sort of the beginning of that. And I think, gravity tells us to build a building from bottom to top. That's how we've always built buildings. Never really thought of it another way, but this building had to be built from back to front because of the way the structure was designed. And so without the digital tools, I don't know where we would have ended up here. So this is the result of those efforts. Again, the virtual construction sessions, having the right people in the room, and really figuring out how to build this building from back to front. It's a CLT structure sitting on top of a concrete slab on grade. Sorry, a suspended concrete slab on block with some warehouse space below. But the sidewall panels were full height CLT, maxing out the manufacturer's capabilities, and then metal angles supported the floor and roof panels. And we were able to use an innovative gluing product, TS3, which allowed the structural engineer to get to a structure on the CLT panels, which is what allowed them to not have any beams and get those clear spans in two ways. So super exciting time and very fun to be a part of because it was it was a tricky time. Really well studied and supported by SciUS and FII and Woodworks and Naturally Wood and FP Innovations. There's a lot of people involved in different pieces of this. The government of Canada that helped us study some of these things and put them into action, put them into reality, from theory to actual execution. I think is what some of the wins were there. Advancements to prefab. I'll move through this quickly. We moved to a fully clad CLT envelope facade panel in this case. We think we're the first ones to do this in Canada, but we went all the way further than Lonsdale. This is just a video of testing that. Was the metal going to oil can? Was how are we going to transport these things? And was this going to work? And so this was just sort of the mock-up piece that did end up in the project as well. And we made the call. We were going to do that. And so you know, I literally snapped this photo across the street from the building when we were doing install, right? So we're doing this, and all of the other projects, we're doing this. So safety, quality, ability to inspect, time, energy, effort, all of these things are considerably changed when we can put this cladding on the floor. We saw up to 6 times labor savings on this, not to mention some other savings and benefits. So, you know, if we can figure this out, we're working on sort of taller wood projects with this now. I think the pendulum starts to swing pretty quickly. And then I'll just sort of move into the install. I got a couple minutes left here, and we'll wrap it up. This is a 1 day of a schedule, and this project was broken down to 15-minute increments. We were able to study this, so we were able to do this. Not a sustainable way to do that, obviously, for all projects, but who's going to install what component at what time? And so we broke the whole project into 15-minute increments. And our claim to fame here, you can see we studied then the actual duration and the estimated duration, and we finished 15 minutes early at the conclusion of the structure and the envelope. So that was kind of cool to have a toast to that. I'll punch through some of these slides quickly and then play a recap video for this project and wrap things up here. And if there's time for questions, I can take one. There's the sort of the CLT support on the walls, the structural insulated panels being flown in. Some of the complexities of putting this building together, you can see here, there's a lot of parts and pieces. It's the elevator core going up and CLT elevator core in this building with some innovative structure there. You can see the level of precision in both the manufacturing, the crane operator, and the installers trying to slide floor and roof pieces between vertically erected CLT panels. They're able to bend them out a little bit and bring them back, but certainly some fine craftsmanship and work done on site there. This one might make you a little bit dizzy. This is the last panel we flew in, so somebody stuck a GoPro or something on the block, and show you how we fly that in. So that's the result there. So 13 days from the top of slab, roof's going on. We pre-installed roof membrane here, so pretty incredible feat. I think, you know, this would typically take at least 4 times that amount of time. Less disruption to the neighbors. We didn't break any lamps, and the neighbors were writing letters to the city about how wonderful the experience was having us in the neighborhood in a way. Great shot there framed up in our office that somebody captured at the conclusion, and a bit of a shot of the interior here. So I'll recap this with a video we made, and then I'll wrap things up.
Situated just outside Olympic Village in downtown Vancouver, On5 is a hybrid mass timber building composed of a concrete masonry foundation and 3 floors of cross-laminated timber, CLT. Designed to passive house principles, this highly innovative building incorporates groundbreaking approaches to insulative CLT assemblies and damage-resistant seismic design. A construction site sandwiched between 2 adjacent buildings on a challenging zero-lot line plot meant that the entire primary structure was prefabricated off-site at a laydown yard a short drive away. The first stage was to build a digital twin of the building in a virtual environment, an important technical simulation which generates significant energy, cost, and logistical efficiencies. There are several virtual build models in action simultaneously, transferring data between systems, allowing the project team, including architect, structural engineer, and relevant subtrades, to collaborate in a dynamic build process, live and in the moment. Using data from the virtual model, load-bearing CLT shear wall panels and interior partitions arrive prefabricated at the laydown yard. While laying flat, insulation, rain screens and cladding is applied to the outside of the CLT wall panels, as foundational concrete work happens simultaneously at the build site. Regular sequencing meetings using the virtual model to emulate full construction meant that the actual scheduled build time was reduced from 20 to 15 days. Even the order in which the trucks were loaded was a consideration. The primary structure of On5 consists of 2 CLT walls which are held together by a CLT floor panel, utilising an innovative adhesive system which allows mass timber to be used for flat slab construction, making it comparable to concrete in terms of interior clear heights, flexible layouts and efficient construction. The building incorporates a resilient slip friction joint system. In other words, it's self-centering and dissipates seismic energy, restoring the structure to center after an earthquake. A unique system which works particularly well with mass timber, since wood is 1/6 the weight of concrete. Taking prefabrication to this stage is a step further for the mass timber construction industry. Having what is effectively a watertight building from day one drastically reduces the dangers, complications, and expense of time spent on site. This is On5, a building typology which makes it easier for cities around the world to develop on challenging mid-block locations.
Awesome. So yeah, lots of support on this project. It was an amazing team to work with. Some of you here, and what a privilege for us to be able to work on this and advance some of the efforts that we've been putting, that I've been pounding my head against the wall for 4 or 5 years on, and actually being able to see these come to reality and in execution. We've been able to move forward with much of this stuff now onto the projects we have in the ground that are a little bit larger and actually less complex. So these projects are so tricky, and there's not a ton of scale there from a cost of construction standpoint. So we're finding our lives a lot easier now with some of the buildings that have much more repetition and scale in them, and applying some of the principles here. So just recaps and lessons learned from the builder's perspective. Of course, that's where I'm coming from here. And we really need to be involved in the project at an early day if we want to try and optimize this as a team. And so this thinker and doer, hard line in the sand, design, bid, build model, it just doesn't work for us. It's got its place, but for projects like this, we just don't see that. I don't think we can go back to that. We don't. We try not to participate in that type of project. Design models first before virtual construction. We mentioned that. We learned that. The process of virtually constructing the building is where the value is, and so it's not a model. It's not a design model. It's a process and a methodology. So. We want to seek partners that understand, have workflows, and are able to kind of match up workflows with ours and see if we can find the integration points to create efficiency and eliminate redundancy. The IDP is the only way to go, in our opinion, certainly for prefab, but for all projects, as I mentioned. And we were able to really de-risk these projects collaboratively as a team versus playing the who's going to transfer what risk to who game in a traditional approach. Like, we're risk managers as general contractors, really, at the end of the day. And so can we de-risk this as a team and have known risks and quantified mitigation strategies and lower the risk premium that's going to go on to closing contract pricing for an owner. So we proved that out in a quantified manner here, and we were able to move this forward, and it starts changing the way projects could be procured and different contract models where the owner can actually have trust and validated quantified trust, not just, shake my hand and trust me, we're gonna do you well, but here's what you can see. You can see what's gonna happen here. So incredible there. We've advanced our quantity takeoff and automated some of our quantity takeoff, and then the guys are now playing with Dynamo and other things, trying to optimize the virtual sequencing process from a technology standpoint. Over my head, I'm just a front man on this stuff, but they're doing some neat things. And at the end of it, I'll just punch through these and say thank you, because I took a little bit too much time, but appreciate you guys having me here today, and learned a lot from all of you, and would love to chat, connect, and understand your perspective on the business and the industry, and compare notes. So thanks.